So I learned a lot from the last tests, and well, I think this new blend has a lot of promise. So I've made a couple more molds. Now what I'm going to do is, well, debind here in the standard kiln, and we'll give another go at the last experiment the same way, but with a little bit of a twist. Alright, one of these turned out pretty good. Yep. So the twist here is I was a little tired of aluminum just because some of the challenges, so I'm taking just a little bit of a break, and I will be sintering or attempting to sinter 17-4 steel. So but we're going to be doing the same exact tests. We're going to attempt a pre-sinter phase, and we're going to attempt a microwave arc only phase, but I have done a little bit of measurements, and I think I have a decent formula for the microwave arc media, and we're going to see if we can refine that a little bit and get our steel parts this time to sinter properly. These mirror finish ones are pretty nice to demold. One of the nice things about having the actual kiln is having a good bit more space and just being able to reliably turn this on overnight and come back in the morning. Again, not trying to discredit the microwaves here, but it is just a very good convenience factor, so I am glad that I have both. But again, you can do everything in the microwave, just requires some a little bit more babysitting. So what I'm going to do is I'm going to take one of these crucibles here, the tall ones. I'm going to be using the silicon carbide heat susceptors, or modular heating elements as I've called them in the past, or whatever you want to say. They will be going right into the crucible right on the top. So we'll take this one out, just like this. As you can see, that has been tamped down, debound, and the crucibles are a good bit lighter just because all the moisture has been, driven out. And so I'll be taking this heating element here, and it's a little easier sometimes with tongs just to be able to get into, drop these down in here. That's going to be placed right on top, just like that. Now, the one thing I've done for the last one was there's a 90-minute starting time with 50% power level, but this new refractory blend that I've made, well, it seems to be a lot more transparent to the microwave. So I'm going to actually reduce the power level down from 50% to probably about 20% to start. And I'm going to give it, instead of a 90-minute sinter time, I'm going to do a 60-minute, just because I don't want any runaway there, thermal runaway, so that I get any... I really just don't want this to burn through my crucible again and have to come in here and take it out last minute. So anyway, starting with about a 60-minute sinter, pre-sinter, 20% power level, I'm going to do the readings. I'm going to do everything on the 1100 watt microwave because that keeps everything consistent with the last test, and I will give a progress report as that happens. And also, pro tip, I had this extra baby monitor, so hooked it up, and that's how I can monitor in the garage without having to actually be in there. Just an FYI, HSA does pay for this, so there you go. It's been 45 minutes of cooldown. I only did 2 hours at 20% power level. The readings indicate that on the outside, this should probably have reached a little bit over 1200, 1300 degrees. I had some other things going on at the moment, so I couldn't get some accurate readings. But I'm going to let that cool down and test it against this one. So we will be doing a microwave arc sinter on this one once it fully reaches ambient temperature, so to avoid any discrepancies on the results. And we will be doing a microwave arc sinter here on the this other steel test ring here that has not been pre-sintered. So hopefully we will see some interesting results between the two. And again, I'm going to wait until that is cooled down to ambient temperature first. Alright, I always have to remember to actually film. Sometimes I just get a little caught up and don't remember to hit the play button. But what I'm doing here is putting a mixture of aluminum arc medium and activated carbon here with the lid, which is going to be our ceramic blanket. And this ratio that I've kind of worked out is going to work for, hopefully, if I've measured correctly, 1 minute and 30 seconds. So that should be just enough fuel to burn for that long. The process that I'll be following is minute 30, full arc sinter, 100% power level, and take out, then rotate and recharge the crucible with another load of media, and do this 4 times. So currently this is the crucible that is strictly microwave arc sinter. I will then move to the here it is, to the pre-sintered crucible and do the same exact routine. Just again, this was had the pre-sinter phase first, but following the same microwave arc sinter, and we will be measuring the results after that. Okay, I'd just like to point out, and although it did not look incredibly impressive, oh, here we go. Now we're getting some arcs. What I would like to point out that after the first 1 minute and 30 second cycle, we reached an internal crucible temperature of 1100 degrees, anywhere from 950 to 1100 depending on the position. And we've rotated, and I'm sure we're getting much hotter in there right now, as you could see from those arcs that were forming. There we go. Those are hot. Alright. We may do this 4 times, I don't know. Might just do it 3. I'm shooting for 4. We are going to go ahead and excavate the singular stage test ring, just the microwave arc sinter. The other one is a little too hot at the moment, but maybe after we get this one out and inspected, we'll have a better idea of what to expect with the next one. So let's go ahead and pull this one out. Alright, so the first singular microwave arc center phase, let me take this mask off, was not successful, but it still had a few bits of beading around the surface. This is the microwave arc center plus the pre-sinter. Pretty hard casing. We're going to excavate this and see what we have. Alright, well, not a total failure. The Pre-Sinter steel, after a little coaxing, was able to be freed from the shell. The pieces in here that are the steel components are sounding kind of hard. The oxidation level on the inside seems to be okay. One thing maybe I could, I don't think it's necessary, but I could add a carbon layer during the pre-sinter phase. I feel like this resulted in a stronger piece. I know it's in pieces at the moment, but you know, when we come take a look at the pile over here, I really had to smack these things open. The shell on these, a lot of people probably don't realize, it forms a shell around the parts, which is very challenging to get off. But what I did notice is that the shell on the if you can imagine, this side over here is the pre-sinter, and this side over here is the singular microwave arc center. This shell was very compact. It was very challenging to get open. To even get that part that I showed just recently, I had to use a hammer and this trowel here and break it open. So there's better ways to do it. But I'm just testing a few of the properties, so I don't really care if the pieces break. It kind of helps me actually to see the differences between the two. Breaking is actually useful for me, in other words. But anyway, again, not a 100% success. It's not a shiny piece of metal like this, but it's definitely progress, and I think I'm onto something with the microwave arc center steps here. So hoping to blend that into my regular microwave sintering, and hopefully end up with some, well, stronger parts. Anyway, thanks for tuning in with me, and hope you guys have a good night.